All right, section 9.3 is titled Applications and Probability. In particular, we're going to do two applications in this section. The one we're going to do today is odds. So, odds. Where have you heard the word odds used? In what contexts? Give me some examples.
Numbers.
Okay, but like what for?
I don't know, like 0, 3.
Okay, so you mean odd numbers. That's true. Odd numbers. That is one of them. That's not quite the odds that they're talking about here, but they do use that word there. You're right. Emma?
Kind of real world example. My mom has a coworker who's all 3 of his sisters passed away from COVID, and so when she told me, she said, "What are the odds?"
Gotcha.
All
So
three.
likelihood, chance, things like that, using it in that sort of a phrasing. Yep, Jordan. The Hunger Games. Somebody always says that one. Thank you. Actually, every now and then somebody does it, and I'm like, did anybody see The Hunger Games? The Hunger Games. And that's kind of this idea of odds or likelihood, kind of like the way you're using it in that word or in your phrasing for your mom. We have a very specific meaning for it, but there's a couple other places that you may or may not be aware that you see odds used. Odds are actually used a lot in gambling. Not encouraging you to gamble, that is not what I'm meaning. But they are. You'll see odds posted for things. For example, odds to make wagers on football games or horse races, things like that. Odds are used when those kinds of situations are occurring. We have a very specific definitional meaning that goes a lot with the ideas that you guys have presented. So we're going to talk about how odds are related to probability, because sometimes people use those words interchangeably, and they're not interchangeable, but they're related. So if you have P of A is the probability of event A occurring, and P of A complement is the probability it does not occur, then the odds of the event occurring, or in favor of the event, are probability of A divided by the probability of A complement. If you want the odds against an event occurring, it's just the reciprocal. The probability of not A on top and the probability of A on bottom. This right here is more than anything just a reminder of what the A complement business is about. If the probability of A is P of A, then 1 minus P of A would be P of A complement. Okay, it's just the other component. It's also, there's another definition that's very related to this, and we almost will use it interchangeably and not even recognize that we're doing it. But when you're calculating, say, for instance, this probability of A divided by probability of A complement, sometimes people will calculate the number of A and the number in A complement, especially when it's something that can be counted quickly, right? The number of things that satisfy the criteria compared to the number of things that don't satisfy a criteria. So we'll almost use these interchangeably, but I'll try and make note to you when we're doing so, just so that you're aware that it is a slight difference. So we're actually going to do an example that's going to be related to this one right here first. Okay? So we have some marbles. There's 8 of them. 5 are red and 3 are white, and we're choosing one at random. Part A simply wants to know what is the probability that we choose red. So the probability of choosing red, we can do this as the number of red marbles compared to the number of total marbles, right? That's not anything new. It's the same thing we've been doing. So how many red marbles are there? 5. And how many total? 8. Okay, so it's a comparison. It's a comparison of red to everything. That's what probability is. A comparison of one item to the whole possible item, every possible item that can exist. Odds is a little bit different. So odds is going to be the letter O. Again, odds of red. And I'm going to do it with the numbering because it's easier. I'll show you the other one so you can see it in a second. But the number of reds. And what we're actually going to do is compare it to the number that are not red. So we already know the number of reds is 5. How many are not red? 3. So this is a comparison of what I want to what I don't want, right? Whereas the probability is a comparison of what I want to anything that could happen. So they're definitely related ideas, but they're not the same. If you were to think about it from the definitional standpoint of the other one, where it's the probability of red divided by the probability of not red, let me show you what happens so you can see that it really does work out. We got the probability that it was red, it was 5/8. What's the probability that it's not red? 3/8. And if you take your fraction and then instead of dividing, you multiply by the reciprocal, what do you get? The same 5/3 that we just did, right? So it does work. It works every single time, and it works just like that. It's just that sometimes when we have probability information, that's easier to use, and sometimes when we have counting pieces, that's easier to use. So we're going to use whatever's easiest, okay? Now, this actually relates back to something we saw back in Chapter 6. That was forever ago, right? In Chapter 6, we saw ratios. Do you remember that? It's the very end of Chapter 6. But one of the things that we talked about when we talked about ratios is that there's 2 different kinds of ratios. There's a part-to-whole ratio, and there's a part-to-part ratio. That's the difference between probabilities and odds. Probabilities are a part-to-whole ratio. Odds are a part-to-part ratio. Do you see that? So this isn't brand new. This is something we've seen before. It's just with a different context laid upon it. All right, so let me show you an example of one where we would use probabilities. This one actually tells us the probability of something happening. The probability for the day for rain is 60%. What are the odds against it raining? So there's a couple things going on. It asks for odds, but it also asks for the odds against. So anytime you're having the odds against, basically what you're saying is that you want the odds that something doesn't happen. So we want the odds that it won't rain. So as I'm doing my odds, I want the odds that there's no rain. And because I'm given probabilities, that's what I will be using. I want the probability of no rain to go on top, which means it's the probability of rain on bottom. Now, they didn't give us a probability in a numerical form that's a whole number or an integer or a decimal or anything like that. They gave us a percent. You can actually use it in a percent. It doesn't hurt anything. So I'm going to just use it as it is because there's nothing wrong with that, and I'll show you why. But it says that the probability that it rains is 60%. So the probability it rains, 60% can go on bottom. So then what's the probability it doesn't rain? 40%. And what you'll see is that because they're both in percentages on top and bottom, there's no need for us to change the way that they're expressed. We can reduce from here. In other words, the percentages cancel. All right, my zeros cancel. That's all good. And then 4 divided by 6 both divide by 2. So this is a 2 to 3 odds. If you don't like to work with the percentages, if that makes you a little bit uncomfortable because you're like, well, I don't know, maybe it's not going to work this time or with the information I'm given, you can change your percentages into decimals, and that's fine too. Okay, any questions on that? Okay, so what we're going to do next is we're going to look at how we go in and out of probabilities and in and out of odds. So if you have the odds in favor of an event, they are m to n, then the probability of the event is m over m plus n. If the odds against the event are m to n, then the probability is n over m plus n. And I can just show you real quick using that marble example how this is sort of working for us. So if you'll remember, we had 5 red. What was the other color? White. And we had 3 white. So the odds, let's just use event red because that's the one we did before. The odds of event red were 5-3. Remember that? So all this is saying is that if I want to change from odds into probability, I take that same numerator and then I add the 2 values together in the denominator, and sure enough, you see that 5-8, right, that I saw before coming into play. And if I want the odds against, I do the same thing. I take the not reds, which was 3, and I add them together in the denominator again to give me 8. Okay, so we're just using them interchangeably, moving in and out with the information we're given. All right, so we're going to have one more example, I think, for today. Example number 3. We worked and did a problem kind of like this last time. We did a couple problems. One problem we did had a 2-child family. We talked about Joe, who said that there's only 3 outcomes, boy, boy, girl, girl, or one of each, right? And we said, well, not quite. And we drew a diagram. We also did a 3-child diagram that was about Huntington's, but the probabilities all work out the same. So this diagram actually looks like that one, just relating to boys and girls. So it says, consider a 3-child family. What are the odds of having all the same gender children? So we're going to have 2 children. This is child number 1, and there's 2 choices. It's a boy or a girl. We have child number 2, 2 choices, boy and girl. And then we have child number 3, 2 choices, boy and girl. And what are the probabilities along every branch? Yeah, 1/2. So feel free to fill those in as fractions or decimals. I'll use decimals this time. Actually, let me use fractions. I want to show you something. There's 1/2 everywhere. Oh, I left one off. Here and here. Okay. All right, so the question asks us, what are the odds of having all the same gender? So let's think about what that means. Well, the odds of having all the same gender is the number of ways of all having all the same, and then the number of ways that we don't. Now, I can think about this in terms of numbers because all my branches are equally likely. If I had like that Paxson rattlesnake example and I did the same kind of a question, I couldn't do that. I'd have to do this with probabilities. It would not work out correctly because not all the branches were equally likely. But here they are. If you multiply along any branch, you end up with 1/8, don't you? Yeah. So how many branches are all the same gender children? 2. The one at the top and the one at the bottom. There are 2 branches that have all the same gender children. And how many branches don't? 6. There are 6 that remain. And we will reduce this to 1/3. I almost mentioned it before and then I got distracted in my mind. Thinking about reducing these, we do need to have a little bit of caution. If the question here were asked the odds of having different gendered children or whatever, and we flipped our fraction upside down and it's 3/1, we have this innate tendency to say, well, that's just 3. But with the context of what we're working at, you have to leave it as a fraction, even if 3/1 equals 3. Because it's still supposed to be talking about a comparison, and it doesn't make sense to say, what are the odds? 3. 3 what? 3-1. If it helps you to think about it instead, you can rewrite it as a colon. like this. So if you don't like the notation where it's written in fractional form, or if you think that you might accidentally reduce something or some, then you could change it to do that at the very end. It doesn't, you don't have to, but you could. In particular as well, we will reduce, we just won't reduce to a whole number. Okay, so we reduced, we divided it by 2, but we're not going to eliminate a denominator of 1 if that shows up. All right, there's one more question. It said, what are the odds against having all the same gender of children? So that's what we're going to see happen here. Now, this is the odds of having the different gendered children, that they're not all the same. So this is the number of ways that we don't have the same gender, and this is the number of ways that we are the same.
I need to know what to put on top and what to put on the bottom.
Hang on. That's a good question. So the way that I always write it is I always write it in a positive perspective. So this phrase against is a very negative connotation word, right? So instead of thinking, what are the odds against having all the same children, I always ask myself, what am I really trying to find out? And I'm really trying to find out the odds that I do have different gendered children. So you'll see that what I write down here is always in a positive light. It's the odds of the different kids, whereas this one was the odds of the same kids because it said the odds in favor of having all the same. So I always write mine and phrase it that way to keep that clear. And then the numerator is the same as that one. So this is the odds that are the same, it's the number that are the same. The odds that are different, the number that are different on top. Yep. So we already did these values. We just did them in the other order. So I have 6 over 2, which is 3 over 1. Perfectly reasonable to leave it that way, but again, if it bothers you, just write it as a semicolon or as a colon instead. Any question on that? Okay, perfectly timed. So I'll stop this now.